Electric charge. Electric charge is a fundamental concept in electromagnetism, characterizing the electromagnetic interactions between subatomic particles. Protons carry a positive charge, while electrons carry a negative charge. In a naturally occurring atom, the total number of protons equals the total number of electrons, making the net charge of the object zero. This state is called electrical neutrality. If a material contains more electrons than protons, it will have a negative charge. And conversely, if there are more protons than electrons, the material will have a positive charge. Particles with the same charge repel each other, while particles with opposite charges attract each other. When the net charge of an object is non-zero and remains stationary, this phenomenon is called static electricity. This can easily be generated by rubbing two different materials against each other. However, even when the total charge of an object is zero, it can still participate in electromagnetic interactions, thanks to the phenomenon of electric polarization. Charges that are influenced by polarization are called bound charges, while charges that can move freely within a conductor under the influence of an external electromagnetic field are called free charges. The SI unit of measurement for electric charge is the coulomb, named after the 18th century scientist Charles-Augustin de Coulomb, who made significant contributions to the study of electric charge and frictional forces. Electric current. Electric current is the directed flow of charged particles through a conductor such as metal, an electrolytic solution, or gas. When an electrical source creates a potential difference, meaning a difference in the energy of the charged particles, these particles begin to move from the region of higher potential to the region of lower potential, forming an electric current. The current is measured in amperes, and the potential difference is measured in volts. Depending on the nature of the current and the way it flows, electric current is divided into two main types: direct current and alternating current. Direct current is a type of current that flows in a fixed direction from the positive terminal to the negative terminal when considering the circuit direction, or from the negative terminal to the positive terminal when considering the movement of electrons. Direct current is commonly generated by sources such as batteries, accumulators, or solar energy devices. Alternating current is a type of current whose direction and magnitude vary periodically over time. The number of oscillations of alternating current in 1 second is called the frequency, measured in hertz. Electrical devices are usually designed to operate efficiently at a specific frequency. Using the wrong frequency may cause the device to function inefficiently or become damaged. Alternating current is widely used in power grids because of its efficiency in transmitting energy over long distances with minimal energy loss. Electric field. An electric field is a region of space where a charged particle experiences a force of attraction or repulsion due to its charge interacting with other charges in its surrounding space. This concept was introduced by scientist Michael Faraday. According to Coulomb's law, the force between charges in an electric field is directly proportional to the magnitude of the charges, and the further apart the two charges are, the weaker the force becomes. Electromagnets. An electromagnet is a type of magnet in which the magnetic field is generated by an electric current. Electromagnets typically consist of wire coiled into a loop. When current flows through the wire, it creates a magnetic field that is concentrated in the core at the center of the coil. The main advantage of electromagnets over permanent magnets is that their magnetic field can be quickly adjusted by controlling the amount of current in the coil. However, unlike permanent magnets, which do not require a power source, electromagnets need a continuous power supply to maintain their magnetic field. The discovery of electromagnets led scientist Michael Faraday to invent the first generator in 1831. Although Faraday's initial invention was inefficient and did not function as a practical generator, it demonstrated the ability to generate electrical energy through magnetism, forming the foundation for the development of electric motors. Today, electromagnets are widely used as components in various electrical devices, such as motors, generators, electromechanical solenoids, relays, speakers, hard drives, MRI machines, and magnetic separators. Electrical circuit. An electrical circuit is a system that allows electric current to flow through in order to perform various functions such as supplying power, transmitting signals, or converting electrical energy into other forms of energy. An electrical circuit consists of basic components such as a power source, conductors, resistors, capacitors, electrical devices, and switches. The common classification of electrical circuits is into series and parallel circuits. In a series circuit, the components are connected in a single chain, meaning the current must pass through each component one after another without any branches. The current remains constant throughout the circuit, and the total voltage is the sum of the voltages across each component. If any component in the circuit is disconnected or fails, the entire circuit is interrupted. In a parallel circuit, the components are connected in different branches. The total current is the sum of the currents in each branch, while the voltage across all components remains the same. If one component fails, the other components in the circuit continue to operate normally. Electric power. Electric power is a quantity that represents the rate at which electrical energy is consumed in a system or electrical device. In other words, the higher the power, the more electricity the device consumes over the same period of time. Electric power is measured in watts. In electricity supply, the total power that the electrical system must provide includes both active power and reactive power. Active power, also known as real power, it is the actual power consumed in a circuit to perform work, such as lighting, heating, or running a motor. Reactive power. This is the power that oscillates between the source and load due to inductance or capacitance in the circuit, without being converted into useful work. Electromagnetic waves. The research of Faraday and Ampere showed that a time-varying magnetic field creates an electric field, and a time-varying electric field creates a magnetic field. These two fields propagate perpendicularly to each other and perpendicular to the direction of wave propagation. This propagation is called an electromagnetic wave. Electromagnetic waves were theoretically analyzed by James Clerk Maxwell in 1864. Furthermore, he demonstrated that electromagnetic waves can travel through a vacuum or other physical media. In a vacuum, electromagnetic waves propagate at the speed of light, making light itself a form of electromagnetic radiation. Electromagnetic waves encompass a wide spectrum, including radio waves, microwaves, visible light, X-rays, and gamma rays. Thank you for taking the time to watch my video today. I hope this video has provided you with useful information. Don't forget to subscribe to the channel so you won't miss any upcoming videos. See you in the next ones.